circuit in Multisim. I hope the Multisim window is visible to you. Maybe I'll zoom the circuit for you to a better visualization. I think it is clear. The same CUC, VCC I've given it as 6 volt, RB 530 kilo ohm, RC 3 kilo ohm, and I have chosen a transistor whose beta is 100. And I told you how to modify this beta. When you double click this component, you have something called as forward current gain. Here you can change the value of beta. And other parameters are same. VB I have taken the silicon transistor rate, so VB I have taken it as 0.7 volt. If it is germanium, you can change this to 0.2. Otherwise, I am happy with the value of VB, and beta I am going to fix it as 100. Okay, see the circuit is very clear. From VCC base, the connection goes here. From VCC corrector RC, the connection goes here. Emitter is grounded, and I am measuring VCE and IC. So I have connected a voltage current common probe, which will measure both voltage and current at this node. So if you measure at this node, the current will be IC, the voltage will be VCE. So directly I'll be getting the Q point. And what is the Q point we got in the problem which we did? It is 3 volt and 3 volt and 1 milliamperes, correct? So we were getting 3 volt and 1 milliamperes. We'll just cross check. We'll just run this simulation to see whether the answer what we got is correct. Yes, see, I have run the circuit. Can you see the circuit is running? The time is running, you see. And we have got the value of VC. See, VC is 3.0418 volt and I is 986 microamperes, or I can write as 0.986 milliamperes, or approximately I can write as 1 milliamperes. Because in the theory we get the answer exactly same, but in simulation it will consider all the properties of your transistor. So the voltage and current will be somewhat near to the actual answer. It is not exactly 3 volt and 1 milliampere. It is 3.04 volt and 0.986 milliampere. Okay. So just if you want to find what is the base side voltage, you can attach one more probe here. So if you run the thing, you will get the voltage in the base side. See, base current is 9.8 microamps, approximately 10 microamps the base current, and VB you see it is 0.7 volt, 3.773 millivolt, or I can write as 0.77 volt. So you can measure all the voltage and current using the probes what you have in Multisim. So here you can see separately you have voltage probe, current probe. If you want to measure voltage and current, you can have a joint probe, which is very useful for all these biasing circuits, because I want to measure both voltage and current at the particular point. So this diagram confirms that whatever with the circuit we have studied theoretically matches the Q point is going to match with the circuital design. Only thing, the values will not be exactly same. It will be slightly, you will have change in values. Any doubts or queries you have in the simulation of this circuit? So as I already given you the link for Multisim, you just have to log in and try simulating this circuit. It is drag and drop, so it makes very easy to design any circuit. Okay, I hope the circuit is